All right, guys, welcome to pre-calculus. This is 1-2-3. So we're going to be talking about piecewise functions. You've seen these a little bit in the past, but we're going to go in a little bit more in-depth today. So to start off, you have a little bit of a scenario here. So Lisa is babysitting. She makes $8 an hour until midnight, and then after midnight, she earns $10 an hour. So she starts with her babysitting at 10 p.m. What would she make for X number of hours? So what I want you guys to do is draw a graph that shows the amount of money which she is earning for the amount of time she is working. I gave you this table. I really want you to fill up this table first. It's actually a little bit deceptive of what's going on here until you actually make the table. It's not impossible. It's just make the table filled out, put in the times, and then once you're there, then try and actually go and graph that. So go and pause the video, answer A and B with the table, and then we'll move on from there. Okay, so now that we're back with this table, what you're going to see is that at 8 o'clock she's worked for 1 hour. So you'd have a 1 in the amount of time she's been babysitting, and then at 9 it's going to be 2 hours, 3 hours. This is 4.5 hours, right? And this is 5 hours, and then 5.5 hours, 6 hours, and then 7 hours, right? So the amount of money earned, well, it's $8 per hour here. So it would be $8, and then $8 more is going to be $16, and then we're up to $24. And now here she's worked an hour and a half extra, so that's going to be 8.5 of that is going to be 4 more, so it's going to be 12 more total. So 12 more on to that, and then we're finally up to at 12 hours getting her price there, which is $8 for 5 is going to be $40 there, right? So we're at $40, and then after that, our rate changes, right? So now we're going $5 every half hour because it's $10 per hour, so it'd be at 45, and then 50, and then 60, and so forth, right? So when we graph that, we should see that standard slope. Oh, this should be this way for you guys. Sorry, it's a mirrored image for me. So it's going up, right? And then once we get to midnight, it'll kind of change as the angle become a little bit more actually steep, because we go there and then change angle. We're going to be going a little bit more steep for the latter part there. So that's, again, you guys have seen piecewise functions before, so I'm not going to spend a ton of time going over those in great detail, but this is just kind of to get us back into that mood. All right, so let's take a look at number 92. So here's a piecewise function in kind of a more standard numerical fashion. So what I want you guys to do is fill out this table, right? So what would the values be of this for all of these, and of this for all of these? So go ahead and fill that out for all of them, and then answer B and C. So we're going to pause and work on that. Okay, so when we find the values here, right, and then we sketch a graph, I'm going to go and pull up Desmos, and we're going to get graphs of those real quick. There we go. So we're going to have our first graph being x to the second plus 2. And then our second graph is going to be 2x plus 7. Right? So the problem is that these are kind of overlapping. Right? So we're not really saying, wait, where's the break? Our first one, the purple one here, is only going to be when we're less than 1. So from this point here and to the left. Right? And then the other one, the black one, this 2x plus 7, that's going to be only when we are greater than 1. So that one's going to start here and then work its way to the right. So we should just see this portion here, and then it jumps down to there, and then continues on to that little portion there. So we get that kind of a shape. One second, let me pull this up. Right, sorry, that actually I accidentally paused. So what we can do here is we can restrict these domains in Desmos. I want to show you that now. It's going to have you do it later. Basically, you write the equation as we have there. Then we want to do the curly brackets, right? Then we're going to put the domain restriction after that. So for the x squared plus x, we want it to be where x is less than or equal to 1. So for the less than or equal to, I just type the less than and then hit the equal sign right after it, and it'll do it. You can also just use these symbols down here. It works just fine too. And now it has restricted it to showing only that portion. Likewise here, curly bracket, I want x bigger than 1 for that portion. So there is going to be our actual graph, right? So when I'm less than 1, I'm following this purple graph, and then once I'm greater than 1, I'm on this black graph here. All right, pull this back up. And then we are asked, what's the domain and the range of this? Well, domain-wise, it's everything, right? It's all real numbers. There are no values of x which we can't use, because everything is covered by either my purple or my black graph here, right? My purple graph will cover everything 1 and lower, because that is just a nice continuous curve from that point over, and then my black graph will cover everything from that is larger than 1. Now, if I didn't have this or equal to part right there, it would have a domain of everything but 1, but with that, we do have every single portion covered. Then range, right? Well, the lowest point that these graphs ever get is right down here at 2, right? So it's going to be 2 and up. So my range is all values of y that are 2 and greater. It doesn't really matter that my purple and my black graph both give me values that are higher than 9, but as long as it's covered by one of them, it works just fine. So I'm going to have a domain of everything, range of everything that is 2 or larger. All right, let's cut back over here, and we'll go on to the next one. Okay, so here is a new, fresh set of a piecewise function for you. So go ahead, pause the video, work through number 93 and then number 94, and then come back to this. All right. So on 93, we graph those, and we can add the domain restrictions to it, right? And then if we go ahead and do that, I'll pull it up, I'll change over to this screen. We have x plus 2, and it is when it's less than or equal to 2. And then we have 1/2 x plus 5. And that's the 2 here. So now on this one, they really just changed the equation ever so slightly, and now we get a graph that looks like this. So we'll see that really these two lines intersect at the exact same point. And that's a pretty important thing here, right? So that gives us the idea of this being a continuous function, right? That we can draw it without ever lifting up our pencil, right? We do have this little sharp edge there that has problems in other contexts, but in this context, it's totally fine. It is a continuous graph for us. So that's the really big thing they're trying to introduce us to is, hey, what does this idea of continuity or it being continuous mean, right? And then, so that's the part here for number 94. All right, then heading on to a little bit of notes here. Like I just mentioned, continuous means that I can basically draw it without ever lifting my pencil. There's a wordy, mathy definitions for it, but as long as you kind of know what it means when you actually see it, that's what actually matters here for us. So again, continuous, not continuous, hopefully it makes pretty good sense once you get the idea of what's going on. All right, so then what I want you guys to do is go ahead and graph these. So try and graph these by hand, so try and sketch them. And then you can use Desmos to kind of verify it, but don't go just straight to Desmos. Try and do them by hand first, and then I'll let you use Desmos in the future. But I just want to make sure you get the idea of what they look like when you graph them by hand. It's a good way to kind of reinforce how these things work for us. So go ahead and pause it, and then do those. All right, so back here, I'm going to go ahead and we're going to graph these and just take a look at what these end up looking like. So our first one here is 2 raised to the x power. And we want that whenever we are less than or equal to 2. And then we want a negative 2x minus 2 whenever we are greater than 2. So we get this kind of a graph here, right? And is this one continuous? I was doing the wrong line. It is +9. That's what I thought it should be. A little bit closer to us. There we go. All right. So this one not continuous, right? So we see that we have this gap here. This one stops at 4, and this one starts here at 5. So it's close, but it is not continuous. So then if I go down to h, h is when we have x to the second minus 2, and that is when I am less than or equal to a negative 1. And then down here, I want negative 1. And then this is just going to be an x. So here, kind of a weird shape here, but this is going to be continuous, right? Because they do hit at this kind of shared point. Awesome. So hopping back over to this, the last thing I want to kind of go over is, can I figure out, hey, are these continuous without going and just graphing them? So what I want you to do is, for these 4, without graphing them at all, either by hand or on Desmos, try and figure out, hey, would these be continuous, and what would have to happen for them to be continuous? So go ahead and pause video, try those 4 out. Okay, so if we want to see are they continuous, what we can do is take the value where it changes which function. So like here, where here's when it's less than 1, here's when it's greater than or equal to 1. If I plug in 1 here and 1 here, I should get the exact same thing for it to be continuous, right? So if I plug in 1, I get 3 times 1 is 3, 3 plus 4 is 7, right? Plug in 1 is 8, minus 1 is 7. So they both are at 7 at x is 1, so it's going to be continuous there. Over here on this one, if I plug in 0, it's still 7. If I plug in a negative 3, it's negative 6. But more importantly, it doesn't matter because, hey, 0 and negative 3 don't touch. So there's going to be that horizontal separation, so it can't be continuous no matter what on that one. And then if we do that for all of these, here's what we end up getting, right? The first one is a function, and what functions and it is continuous. The second one, it's not going to be a function because it's not continuous. And then the third one, it is a function, but it is not continuous because, again, if I plug in the 4 and the 6, I'm going to get different values there. And then over here, plug in the 2 and the 2 here, and it's going to be it's going to be a function, but it is also not continuous because they don't meet at the same point. All right, so with that, here is our homework for 1-2-3, 96 through 102. I will talk to you guys next time.